Hi guys, so welcome to yet another live session by MyCaptain, organized in collaboration with Qfuss, and a huge thanks to the Qfuss team for arranging and coordinating with these amazing mentors. Well, now's the time when we welcome the speaker of the evening, Piyush Kumar. Hi Piyush, how are you?
Hey, hi. Uh, yeah. Can someone clarify me if my voice is clear?
Yes, your voice is clear, but your video is not
Yeah,
available.
yeah. One second. Actually, it's showing it cannot be. The host has stopped it. Yeah,
Okay, try again. I've just made you the co-host.
yeah. One second.
Yeah, great.
Okay. Yeah, it's visible.
Yeah, it's visible.
Yeah.
So, for those who don't know, Piyush did his engineering from NIT Uttarakhand in computer science, and now he's a software development engineer at Amazon. And today he's going to deliver a session on starting a career in machine learning. But before we begin, a gentle reminder to all of you, instead of chat box, why don't you guys use the Q&A box for questions? And if there are any technical queries or comments that you'd like to tell us, maybe drop them in the chat box. And without further ado, let's begin. Piyush, over to you.
Yeah. Yeah. Sure. Thanks. Okay. So I think let's start with the what is actually machine learning and how actually it is being a hype has been created about machine learning that it's the best job of 2021. So let's understand what actually machine learning is. So if you see what machine learning is it's just like giving your thinking ability to your system. So how we give how we train a system to just think like a human is we gave them data. So suppose just think if you have seen something in past or something, you are able to answer it in the future as well. So the same thing we do it with systems as well. We try to feed them data. So data act as a heuristics. That heuristics is basically you can ask them data on which they make some decisions, and that is how that machine learning works. So everything behind machine learning is all about data. So that's why it is told that the next big resource among the world will be data. So if you have lots of data, you can train whatever machine you want. So a basic a real-time example of those things is you can see self-driving cars. Yeah, right. So how those self-driving cars works is first you have to train a machine. So for training a machine, what actually happens is real-time drivers, they fly on the road, and all the how they make a decision when to change a gear or when to change the steering wheels, all those are recorded as a data. Now all those data are actually fed to the computer, and when actually it sees a similar kind of data, it takes a similar decision what the driver took. So suppose the when we were passing a data, the data was if someone comes in front of your car, apply a brake. So when the computer sees a similar types of event happening in front of them, so it will apply the same logic on that. So when a computer sees okay, someone is coming in front of my car, apply a brake, because that is a part of my data on which I'm trained, right? So this is how machine learning works. So machine learning is nothing fancy. It's just how you pass a data and train your systems. Now if you see like as the webinar suggests, starting a career in machine learning. So machine learning has multiple components. You have to be very good with mathematics. This is actually being ignored by most of the people. Mathematics is not required because everything is defined in Python. We can use models already created and train our thing. But actually, if you see a long-term thing, you should be aware about the mathematics behind it. Because at certain point of time you have to apply your own logics. You cannot use some pre-trained models and those things. So you should be aware of mathematics. Now if I talk about mathematics, what actually you should know. So there are a few things that you should be very much aware about. Its first thing is you should be very good with differentiation and integration. That is the two things that you should be very good at. Apart from that, the major thing that you should know is statistics. So what is the mean, what is the mode, those things, how you can process the data, you should be very much aware about. Because if you see a data scientist or someone working in machine learning in like organizations, they spend like, whenever you start working on some projects, you spend around 80% of the time, or most probably 75% of the time, like cleaning the data, or making a data that you should feed to the computer. So you should actually not feed any of the data that is not relevant to that model that you're training. So like data cleaning and data processing becomes a very essential part. So in that sense, like statistics comes into play. So like if I talk about statistics, like how do you think, like, so just take a simple example, like just take a Netflix example, that how you see a recommendations on your systems. Like when you watch a movie, the next movie it's recommended to you. How it is recommended? It is based on your like previous activities that you performed. Like what is the genre that you are watching, or what is the like heroes that you like, or what is the like creativity you love into. So based on that, it recommends you the next movie. So now if you see a data set of Netflix, like if you see it has billion of the user, right? Now if you pass that billion like data set to your system directly, it will take like 5 or 6 years to train your model, right? Now that is not relevant. And also, like if you talk about resources, like it will take lots of resources. Like if you talk about like any cloud, generally you train all your models on cloud, because these are very large models and it will take lots of time. So in that sense, the resources are very like costly and those things. So why data cleaning comes into play is like, if I want to train my model on what is my next recommendation, I cannot pass a data like, okay, you pause the video at this point of time. That is not relevant. So basically, when you start with a career with your machine learning, and whenever you design a model, you should have a statement. Okay, and with that statement, you should have, okay, what is the relevant feature that I should have, and based on that, you should extract the feature out of the data set. That first, the data set will be very big, and you have to like compile it and make it short to feed your system, right? And now when you feed it to the system, now you can encounter multiple problems there, right? The first thing is that the data may not be completely filled. You may have some null values. Basically, in computer science, we tell it as null values when you do not have any data with you. So that data you need to fill up on, right? Now to fill that data, there are multiple ways you can fill. Suppose I had a column where I was able to see the weather of 7 days, right? But on Thursday, my weather was not available. So what I can do, I can take an average of 6 days and add it to the like unknown value, making it, okay, that could be the close value that could have happened on Wednesday. So that is the way like we just try to clean up the data. Now the second thing is like, after you get all your data processed and those things, now you have to apply it, pass it to your machine learning model, right? Now the passing that machine learning model requires lots of things. So you should be first is like there are 2 or 3 languages which is very popular these days. The first is Python and the second is R, right? So I think if you are like very much interested in machine learning, you should not be like any language dependent, because if you see the platforms like Kaggle, right? Kaggle is like one of the very like rich platform where like multiple data scientists, multiple like machine learning enthusiasts, like they come up and code, right? So Kaggle is similar to like HackerEarth or HackerRank that you have for coding. It's a similar like replica for machine learning, right? So what happens actually is like you have a problem statement and you just have to pass your like predictions, right? They do not care like which model or which like language you use. Ultimately, your like the final target is making the predictions, right? So now if we talk about like what language you should use for this, the major languages are Python and R. Now out of this, like if you want to like make very good with statistics, I would recommend R. But if you want to like work more on computer visions or like real-time projects, I think Python will be good for you. And if you are just starting with your like career with machine learning, using Python will be a little bit easier, because if you see the difference between Python and R has a very rich like stats libraries. But if you see based on the learning curve, Python is very easy to learn and you can easily start with that. Ultimately, like once you like become a like grown up scientist or something, then you can start parallelly working on both like Python and R. So yeah, that was the first thing about like languages that you can use. Yeah, and the second thing is like once you like come up with all the data and languages that you should use, then the next thing comes is like what models actually you should use. Now there are multiple models that are available to us. Some are like pre-trained already, on which the data is already fed, and like you just pass your new data and make up predictions. But ultimately, like you should, but ultimately, like you should be more aware about like how that models actually work. So if you see something like, I assume that most of the people who have joined are like have like little idea about how machine learning works. So let's start with some one basic model, like take it as a logistic regression or linear regression, right? So basically it's just like separation of like how we separate the two classes. Suppose let's take an example of cricket, right? Now based on the scores, like previous score we had, we just want to predict that whether a cricket match will be won by a particular country or not. So we check on that, right? Now we see that the data, based on the previous data, we do not see any like the chances of this cricket team winning. So we predicted, okay, the team cannot win, right? So this is the way like how we use like logistic regression and those things. So that is the what you have to decide actually. Now, and like you can train on multiple models, like you can have decision tree, you can have logistic regression, you can have stochastic regression, but ultimately your point should be like on which model you are getting more accuracy and on which point you are getting more like correct predictions, right? Now if you take about like once you process with all those things, the second thing comes about deployment. So I think if you are just starting with machine learning, you won't get actually this chance to deploy until unless you are working some organization. So if you see like how data scientists actually works is like they create a model, and how their model and how their work is actually judged is because, like, suppose take example of Netflix itself, right? Now in Netflix, suppose I created a model of predictions, right? What will the user watch next? Now that prediction is actually judged based on the model that comes actually to the users, right? Now if you're a Netflix user, I recommended you 5 movies, and out of that 5 movies recommendation, actually how many you clicked, right? Now if a user doesn't click on any of the recommendation, that means my recommendation was wrong, right? Now if the user clicks on some recommendation, that means okay, at some point of time my model is actually working and my recommendation is working, right? That is the way like how we keep on iterating and improving our models, like, right? We just keep on analyzing the user behavior and see, okay, our model is working fine or model is not working fine, if the accuracy is correct or not. So that is the way like we just try to keep on improving our models, right? Now that is like little bit intro about how machine learning works. Now if you see like how you can start your career in machine learning is like you should be like first focusing upon like one of these two languages, like either you should take R or you should take Python, and be very solid with those concepts, right? You cannot always keep on referring to Google or something like for checking, okay, how should I use those things. So you should be like very much solid with one of the languages, like either pick Python or R, or spend like some time, like 20 days 30 days on that, and just brush up all your skills on that. Now once you start like once you're comfortable with one of the languages, you can start implementing with small examples, right? I think you can start with Kaggle itself. So in Kaggle, what you see is like you have some basic problems. Like the one is very famous problem, that Titanic prediction problem. Like if the Titanic is sinking, how many people will survive, right? That is a survival problem that whoever like start with Kaggle, they start with this first problem, right? So in that, actually what happens is like we have given an Excel sheet. The Excel sheet contains like lots of data. Okay, this was female, this was the age, and this and he survived, right? Now these are your training data set, right? And now once you train your model on this data, you have to predict that, okay, if someone says if I have a person with age 70 or this much heuristic, what will be the prediction for that? So you have to just upload your like prediction on that, and you can start like slowly with that part. Now this is one of the platform, like Kaggle is one of the platform where you can actually start. The second platform is like HackerEarth. HackerEarth is like good if you are comfortable with machine learning and you can start competing there, right? So in Kaggle, actually multiple companies like they host their coding challenges, like it's basically based on machine learning itself. So they will host their challenges and they will ask you to make predictions, right? If you see very good companies like Intel or even Amazon AWS, they host their like contests there, right? They all are based on machine learning itself. Now if you think now starting a career in machine learning, right? Now if you want to start a career in machine learning, you have to, like, as I said before, you have to be very good with mathematics. So if you see like some big companies like Google, Amazon, or Facebook, they generally do not hire much people who are just a fresher, like they just pass out from the college, or like they are BTech qualified. If you see most of the data scientists like who are being hired, they are basically PhDs, right? Now you have to slowly start with such platforms like Kaggle, right? You have to come up with your things like, okay, I'm capable of solving machine learning problems, I'm capable of solving like high level problems, and you have to prove yourself, right? Otherwise, if you see the basic qualification of any data scientist or machine learning, it's like MTech or PhD, right? Because how these MTech and PhD works is like they work on real time problems, right? And they involve lots of mathematics, lots of research, and they do lots of research. They generally do not use an already created model, but they try to create everything from scratch, right? So that's why like most of the companies that try to like go with PhD people or MTech people. That is the reason like that is the reason like we should always be very good with the like the basics that we have for the machine learning, right? Now if you see about like just take example, like you started with working on like Titanic problem on Kaggle. Now if you're just a beginner, right, you will face lots of problems. Like you won't be able to judge like how to read Excel file into a Python, or how to like predict a model, how to upload the model, how to improve your accuracy. I think you should ignore those things because you're just a beginner, right? Now what you can actually do, Kaggle has a very good thing is like they provide a solution for all the problems that they give. So if you see, there are lots of people, right? You can find even people from Google, or not even from India. Like most of the like 80% of the people are outside India, right? Now you can find the solutions actually. So in Kaggle, you have a dashboard where you can find all the solutions. You can see that how they predicted, what model they use, and what are the steps they followed, right? So this way, like actually you can improve your learning curve. Like okay, first time I was unable to predict the model. I went to the notes, I went to the other solutions, I watched it. Okay, this is the way you should predict. And next time when I will do something, I will just try to apply the same, right? Now if you see, like there are basically 4 or 5 steps that you should start with machine learning. The first step, which I already covered, is like one of the languages you should pick. Second thing is you should start with one of the platforms, whether it be Kaggle or whether it be HackerRed, and be very solid with like either one or two problems. The third thing which I would tell is like including collaborations, right? Just ping like people on LinkedIn, just ping people on like Kaggle itself, and just try to get like learning out of them, like how they learn, how they think. Like they will share multiple blogs with them. Like, so one of the things which I would like to tell, there's some blog called Towards Data Science. It's available in Medium, but actually it's paid. So actually what you can do is like you can like, it's like 60 rupees per month. I think that is okay for everyone. So you can go ahead and take that thing. That is very good. So people like multiple developers, they try to post there. So you can find posts like how you can start with machine learning, or what is the, if you have this statement, then what you should actually take the decisions. So I think going with Towards Medium is also very good. Now if you want like if I would say like if you are, I assume like if some people are like from BTech here, so actually what you should do is like you should not rush towards like directly jumping into data science, but you should slowly start like into jumping into data science. Because right, I think most of the companies, if you see like well-established companies, they won't hire actually freshers as data scientists, right? So if you see the eligibility of any like well-known companies like Google or Amazon or Facebook, their basic eligibility for like data scientists is like 8 years, right? You should have experience of 8 years with like data science. Now you should slowly start as a software engineer, and you can start slowly into the domain of machine learning, right? This is how like you progress into machine learning, and by the end of like 5 or 6 years, you finally proceed into data scientist, right? Now why they have so much like concerns about the like eligibility for a data scientist? Like if you are hired as a data scientist, right, you have lots of responsibilities, right? whatever model you create, it's like deciding the company's profit or loss, right? If you say Netflix, right? If you design a model that is predicting wrong, then what actually will happen? Like will start suffering loss, right? That way, like the model that you design becomes very essential for you, and you should like be very solid with that part, right? So that is why like they want like well-groomed people like who can actually work in data scientist roles. So just that is why they have eligibility. Do not think that you cannot like finally jump into the role of data scientist or something. It's very much feasible, but you should actually have to work a lot on that, right? Now what I would actually recommend is like if you are working on data science part, right? There's some book called O'Reilly, O-RELLY. So that books are very good. Like you can go through one of the books and you can start with that. So there's something called Start Basics of Machine Learning that is from the same publications as well. So you can start learning that book like slowly. So that will give you a gist of all things that what machine learning involves in day-to-day life, right? Now with respect to like how you can like try some problems is like just suppose that you're working in your college days, right? And you just want to predict that whether it will actually one of the students from like IIT Roorkee, they made a like model that will predict earthquake, right? How they predicted the earthquake is like they have lots of seismic like graphs, right? Now that seismic graphs will act as a heuristic for the model that they're training, right? Suppose in future, like if we see similar seismic waves, we can predict that some earthquake is coming to us, right? So that is how like you can apply machine learning. You can just think of any real problem, right? There's some challenge going on like in Kaggle itself, like about coronavirus, right? You can predict that what will be the spread of coronavirus. If some people are affected in this much area, what will be the like spread into other areas or something. So that is how like you can actually just try to think in some real-time examples that where you can apply machine learning. So I think that will be a good place to start with. Like just pick up any real problem. It may not be like very significant for you, but it will provide you solid learning concepts there, right? You could apply lots of things like but if you see like how you learn in like real life and how you actually come into organizations, like when you do like machine learning in your college days or as a beginner, you will have a data set that is size of 1 MB, 2 MB, 3 MB max, right? But if you see organization, like when you come to organizations like Facebook or Amazon or Google or Microsoft, they have very huge data. They have billions of the customers, they have billion of the data. So actually you have to be like so that's why I told like processing the data, cleaning of the data becomes very, very important. That how actually you should process the data, because just think that if you feed like 1 billion data to your system, it will have 1 billion rows, right? Now just to iterate 1 billion row, you will take like more than 1 year, right? Just iterating through 1 billion rows, and again training will take another 2 or 3 years, right? So that's why if you see any data scientists, they will always focus that you should spend like 60 to 70% of the time cleaning of the data, right? So that is what like you should be very much clear about, that data handling is very important, right? Now if you for statistics, I would recommend that everyone who is planning to start for machine learning should be very good with stats. So for stats, you should be like you should have a book like Introduction to Stats, right? I do not know the complete title, but you can search it on like websites. You can get the like PDF, or you can even buy the solid book. So it's like starting Introduction to Stats. Now that book actually contains lots of things. Like it will start from very basic, like okay, what is median, what is mode, and ultimately you can see like how you can actually plot bar graphs, or like you can see that what is the missing data. You can predict all those things, right? So all those things becomes very important. Like whenever you start with machine learning. Now with respect to stats, right? You should have very like few examples should be very clear to you. Now the first thing is like okay, how my data is, right? Whether it is weighted towards one side or whether it's weighted to the other side, right? Just take an example of cancer prediction, right? So if you see the data, right, 99% of the data will say that you do not have cancer. Only 1% of the data will say that you have cancer, right? Now, because the number of patients having cancer is very low, now if you feed the same data to your model, like actually what will happen that the model will become biased, right? Now if the model become biased, because 99% of data that it has seen says that you do not have cancer, right? Only 1% of the data it says that you have cancer, right? Now in that cases, the cleaning of the model, like how you should balance the classes that you have, whether it is yes or no, that's become very essential, right? Because this is how actually you're judged on how your model works and how well you are a data scientist, right? Because ultimately all things goes on in predictions, right? If you are able to predict 99%, you're you're very well groomed data scientist. If you're not able to predict properly, then you need some like work towards the way you are handling the data, right? Now yeah, that was a little bit of like how you should start with machine learning or something. Now with respect to like platforms you should use, Kaggle I have already told, HackerRank I have already told. In HackerRank also they host multiple platform, like multiple contests there, and you can just start working on that as well. Now if you yeah, I can actually see one question, like if you have the courses, like how actually courses works. So there are few places like actually you can start with. One is Udemy. Udemy is good actually. Apart from that, you have something as Coursera. I do not know how many of you have heard, but Coursera is very good actually. Coursera, you can go ahead and like start learning on that. But if you see Coursera, that is actually paid. But some of the institutions like IITs and IITs, they have free access to that. But I do not think everyone could have on that. There are few places like Coursera, edX. You have like edX, but if you see Coursera and edX, most of them are paid, right? Now, now, if you see with respect to content and with respect to payment that you have, I think Udemy would be very good for you to just give a basic idea of what you can actually do. So if you see Udemy, you have multiple courses like starting like beginner till advanced level, right? So I think if you see Udemy, it will cost you around 400 rupees for a course. I think that is okay to spend, because ultimately you're working towards your like knowledge itself, right? Now if you spend like but if you see multiple people, like they join the courses but ultimately they won't complete, right? That is actually not doesn't make a very good sense, right? If you start any course, you should complete that properly. Now, if you see Coursera, in Coursera, there is one professor, Andrew Ng. He is actually from Stanford. His courses are very, very good. If you're not able to actually buy any Coursera courses, actually what you can go ahead and you can find the downloaded videos as well. You can find downloaded video as well for the professors or that lectures, right? It's available on YouTube itself. On YouTube also you can find the lectures from Stanford. So in Stanford they have multiple sessions, right? So it's like session of summer. There's two, just think of semesters, right? So after every semester they upload their lectures, right? Now if you can see all the lectures from the professors of Stanford on YouTube, it's free of course. It's available on like Stanford. You can just search Stanford lectures on YouTube. You can get all those things there, right? Yeah, that is pretty much about that resources that you're talking about. But if you're like trying to save money, you can go with Udemy and parallelly start with like YouTube Stanford thing. And if you want to like spend some amount on certification and like those things, you can go with Coursera. Yeah, and one thing which I would like to clarify is that do not take courses just for certifications, right? Because certifications board ultimately matters, right? So if you come to any of the like company hiring, so they won't care about what you have written on your resume. It will not matter, right? Ultimately they will give one problem to you. If you're able to solve it on the spot, they will hire you. Otherwise they won't hire, right? They won't care about certifications that you have. So I would recommend that focus on learning instead of getting certifications. That is pretty much about the courses that you have. So on the like highlight, you can say that Coursera, edX, Udemy, and Coursera, Udemy, edX, and like that Stanford lecture on YouTube, right? All those 4 resources you can use it for learning, right? And apart from that, like yeah, I can see actually one question. So what is a good book for stats, right? You can see, yeah, I can tell you one book. The book is called Elements of Stats. You can search it on like that is a very famous book. You can get it on the first search itself. So that is a very like huge book actually. You cannot complete it even 2 or 3 years. but you can get everything what you want in that book, right? It will contain everything, right? So that book is very good. Yeah, I think that is pretty much about the courses and those things. Apart from that, there are few like they there's something called, like, as a BTech students, or I do not know how many students are BTech here, but there's something called as NPTEL, right? NPTEL is one of the platform that is hosted by IITs. You can find like multiple lectures of all the IITs there, right? IITs includes like IIT Bombay, IIT Delhi, IIT Hyderabad, everyone they included, right? Now NPTEL, what actually happened is like very orthodox courses, but actually it will give you like complete gist of all the basics of machine learning that you have, right? So if you see, like, it contains lecture from IIT Hyderabad, it contains lecture from IIT Bombay. You can go ahead with learning from NPTEL as well. Like that, NPTEL is completely free of cost, and you can also get a free certifications there, right? Yeah, so NPTEL is one of the good resources in that area as well. And like apart from that, like what I would recommend is not just completing up the resources, because if you see all the courses, whether it be Udemy or whether it be Coursera or something, they will give you one project at the end of every course, and you have to complete it to get the certifications, right? But if you see that projects that you actually like try to implement at the end of the course, that is like very basic, right? That is very basic. Ultimately, what I would recommend is, like, once you complete a course, just try to come up on the platforms like Kaggle or HackerEarth and just try to implement, right? Because that is what is expected from you, right? Now you should actually be aware of predicting the real time like situations, like predicting coronavirus or something. Just do not go on the title in that things may look very difficult for you, but once you see the data, you will actually see that, okay, I have learned this, I can apply this. Do not hesitate to submit your submissions even if you like have 60% of accuracy, because ultimately that is how that models are designed. Like if you see the submissions, right, if you see the best submissions, it was submitted with the accuracy of 60%, and by the end of 15 or 20 submission, it got an accuracy of 90%, right? So that is how like we iteratively like improve our models and keep on improving, right, with our predictions. Now with respect to, like, I can see one question on deep learning. So deep learning is like I would say, like, if you are focusing on deep learning, you should be first very good with the basics of machine learning itself. So like deep learning can be like multiple things, right? Deep learning, there are basically few things in like how like machine learning actually works. There are few components, right? One is working on images, one is working on text, and one is working on like you do not have anything, right? You just have watching video and just try to predict in real time, right? So if you see like text, it will somehow go to NLP, that is natural language processing. If you go to computer vision, it will like mostly go to deep learning part, because deep learning, you have to like if you see an image, right? Basically, when you see an image, you see one like small image, but actually it's a pixels of like lots of pixels that is actually creating that image. So just try to understand that how deep the data is, right? Even for one pixel, one image, you have like 5,000 rows, right? Because it has 5,000 pixels, correct? Now, if you see some real-time example of handwriting recognition, that is how that deep learning concepts come into play. So yeah, so that is what like deep learning is. So I would recommend that once you start with like completely confident with machine learning, trying to create one few models, then only you should start with deep learning. And with respect to courses that is available for deep learning, is like I think I'm not much aware about Udemy and like how edX has, but Coursera has like one course on deep learning as well. That is from Andrew NG only. Apart from that, like you have like deep learning session from like Stanford as well. That is available on YouTube for free, of course. Now, I can actually see one question that, can you suggest me some basic project for a beginner, right? Okay. Now, as a part of basic project, what I would say is like just try to grasp all the knowledge that you have for machine learning. Just try with one simple problem of like handwriting recognition, right? So suppose actually what will happen is like if you do not consider as a like computer vision problem, because you can ultimately convert all the like image into a row, because that would be a pixel, right? So it ultimately will converge into a data set of Excel sheet, right? Now you can actually start with the like project on like handwriting recognition. You can just try to predict, okay, just do a short example itself, like take your 5 or 6 friends, take their handwriting and just try to predict, okay, whose handwriting can be this, right? Ultimately, like you can further enhance to a like real time situation. Like just take it as an example of bank, right? How that bank actually works is like they have something called as machine learning model itself. So whenever you try to sign, they try to match your sign, whether it is like false or correct. They will pass your sign and they will try to see whether it is correct or not. They will try to predict, right? So that could be the enhancement of your simple method that you can take in the real time thing, right? Yeah, I could see when we say most people say. Yeah, so we can get, what role can you get in company in AI robotics? Okay, so I'm not very much aware about this AI robotics part, but if you see some companies like Qualcomm or Intel, so they actually work in this domain, right? AI and robotics. And basically, I would tell Intel is like very like working for a long time in this part. Apart from this company called Nvidia, Nvidia is also like very like starting, like they have also established some like development centers in India. I think it's in Hyderabad or Bangalore. So they are starting like there itself, right? Now, if you want to apply in these companies, basically what I would recommend is like you should first create a resume very properly. Now you should add all your projects there. Basically, I would say like if you add any of your projects, just add a link to your project that you have. Basically a Git link, like GitHub link. You can upload your project and add a GitHub link there, because when you say like I worked on handwriting recognition, right? So people actually want to know, okay, what models did you use? So that things you cannot actually add in a resume. So basically what people do is like you can add a link for your GitHub profile, and people can go and see your projects there, right? So this is what, right, you can have. But I would say like do not completely focus on like ML, like becoming a data scientist itself, because as I told, like it requires a lot of like experience for you. So if you see me, I'm not a data scientist, right? Because data scientist requires more than 10 years of experience, right? I'm working as a software engineer itself. So just do not rush upon the designation that you have, right? So you have to slowly start with all those processes, because if you just keep on pushing, okay, I want to just directly join data scientist, ultimately I do not think that you won't be able to convert there, right? So ultimately you have to start slowly. Apart from that, you can see that there are some, I would say there's some startups, right? They hire software engineer in the role of machine learning, right? So that role is very useful, because ultimately you will get a chance to work in like machine learning projects, machine learning models. You will see how organizations work. So I would say like if you are like if you want to start, you can slowly start, but ultimately you should not like think of like directly joining as a data scientist. That is very difficult, I would say. At least not in like companies like Facebook, Google, Amazon, or Microsoft. You cannot actually not get a data scientist role directly into these companies, right? Now, okay, I would say, okay, I'm not aware at what is DS and DL in the size of data to manipulate. This all matters. I'm not very sure. Maybe if you can like elaborate the full form of DS and DL, I would like to answer that. But now with respect to I think that was all, like you want to how you can actually start with like machine learning, how actually you can start a career in machine learning, and how actually you can like transform from like software engineer to data scientist role, right? Now yeah, now for my part, actually in my BTech, actually I did some research work as well. Like I used to do like there are few papers which I published as well, like few research papers. One of them is like number plate recognition, right? Number plate recognition, actually how it works is like suppose just understand like you have a traffic on the road. You do not have any policemen on the road. Actually, what will happen? The camera will be there that will ultimately capture your number plate, right? It will take out a number from your car and it will feed it on the system. Right? Now, how machine learning actually come into this role is because if you see any frame that you see on the like camera or TV, you do not actually see directly that number plate, right? You see like lots of noises. That noises can be in the form of cars, that can be in the form of trucks, leaves, etc. Right? But ultimately, your role should be like extracting that number plate out of that noise, right? Now that is how that machine learning comes into role, and yeah, that is how we do that. Now, yeah, okay. So what is the difference between data scientists and data analysts, right? Now, data analysts and data scientists are like two different parts of coin. Like there is no relation among them, right? Now, if you see data analysts, like data analysts are, I would say like it differs from company to company, but data analysts are basically like they work upon data. They help in like okay, so just take it as example, like okay, I want to take this decision, like I want to introduce this feature on my platform. I want to say that whenever user watches any movie, just recommend him this movie, right? So the role of data analysis is just to like analyze the data and pass it to the like upper level. Like upper level could be like data scientists or software engineers, and software engineer actually just try to work on those data, right? Now, data analyst could be like so first thing is that data analyst is not equivalent to data scientist. Now, data analysts, their role, they do not actually work on like machine learning things. They work on like data, but most of them are confined to only like working on stats or cleaning up the data or what data is important, what data is not important. Ultimately, their role is like it is confined only to data, right? But if you see data scientists, right, their role is like taking up the data, creating a model, deploying it to the like AWS or cloud, and passing it to the customers, right? So that is like a huge difference between data scientists and data analysts. So data analysts, you do not have any requirement there even for data analysts. You cannot be you can be a data analyst even if you're not a computer science engineer, or even if you do not know any machine learning, right? You can be a data analyst, but for data scientists, you should be like very good in machine learning, ML, AI, those things, right? Because data analysts are very confined. Data scientists is like widespread, right? It has to do lots of things, deployment, training, like testing, everything they have to do. So they are not the same, right? So this was the answer for that. Yeah, I think that is pretty much from my end. Like if you have some questions, please post it. I will take it up.
Yeah. Looks like our mentees have a couple of questions, Piyush. So let's get to them one by one. One of the mentees is asking, is it a prejudice that a job in engineering is very stressful with no flexibility in work hours, or is there any truth to it?
Yes, so I do not know that what was the reason of asking this question, but it depends actually. So if you like, so if when you start your like career into organization, so when you're a BTech student, you can bunk your classes or even you can roam here and there, but ultimately like when you come to an organization, you are confined to your work, right? Now whenever you work in some organization, you're given some task, okay? So these tasks you have to complete in this much days. Now you do not have to take any pressure until unless you're confident that you can work in that much days. So there is no pressure actually. So why would I say that some people like project that on pressure is like when actually you're not interested in some role and you join that role, I think that will act as a pressure for you. But if you're like very much interested in that role, ultimately you will love like working on that field, right? So if you see like I do not feel like any like stress or something based on my work because I actually love like to code and like work on softwares and those things. But if you do not like if you do not have any interest in software engineering and ultimately you come into that domain, I think that will cause a problem for you, right? So it's not about anything called a stress or something. It's like how you balance between the work and your life, right?
Vaibhav is asking the meaning of deployment. Could you please explain that?
Yes. Okay, I would say. So suppose when you create your model, right? So locally you created your model, right? But okay, I created a model on my system, right? But how the customers will use that, right? Now, deployment is basically an intermediate, right? You can say it as an intermediate between customers and your model, right? Now, when you create a model, right, you save it. Okay, this was my predictions. Whenever I face this, I will do this, right? Now, where actually you will put that? You will put that in cloud, right? So how you put that in cloud is called as deployment.
Okay.
Now for deployment, you use multiple things like Apache, you use, right? AWS. In AWS, just take example of AWS actually, right? In AWS, actually, what you can do, you can just train your model and create a link for that model, right? Now that model is actually like deployed. So if someone wants, you can share that link and they can use it, right? Now, if your model is like placed into some central system, that is called as deployment, so that other can actually use. Yeah, that is what deployment is.
Okay, okay. I hope the above that answered your question. Moving on to the next question. Is Python good for machine learning? I think
Uh,
that's what the mentee is trying to ask.
sorry, I didn't get. Can you repeat that, please?
Um, is Python good for machine learning? I
Uh,
think,
yes, yeah. I think that is a very obvious question. So when I actually started with machine learning, is like I was very much like thinking like which language should I use, like Python or R. But Python is like one of the language that is covering around 70% of the models that is built on these like current
oh,
days. 70% of the like things are built on Python, and like 30% are built on like R systems. Now if you see Python, right, Python is like very easy to grasp. Like it doesn't have any like like declare a variable or those things. So the syntax of Python is very easy to learn. Apart from that, it's a like open source kind of thing. Like people add their model whenever they train, they keep on updating the libraries and those things. So that Python becomes very easy. But ultimately, like you can achieve the same thing with R as well, right? But if you see like with respect to how you can begin with, is like I would recommend Python to go with, right? Python is like one of the top languages that people use it for machine learning.
right, right. Okay, so how does pursuing masters in statistics help in becoming a data scientist?
Uh, yes. So if you see like as I told, like stats is like very important thing, like to become a like grown up data scientist, because ultimately you have to decide like, okay, this was the thing this I will do. So that is what stats is all about. So like stats give you a base for becoming a data scientist, right? If you're very good with stats, or you're very good with like you have done pursued some courses like MTech in stats or something, that will actually help you a lot. So if you just take any model, right, just take any real-time model, so you are given a huge data set, right? Out of that huge data set, you have to process that, okay, what are the things that I have to use. So when to do that things, right, you have to know, be very much familiar with stats, right? You can see there's something, I would say, some term as correlations. What actually correlation is, like suppose I have a data set. Okay, this was the weather. This was the prediction. Okay, it rained. It didn't rain, right? If I see that there is some correlation between two columns, that whenever this column has this value, the prediction is always true, right? I do not need other columns there, right? If I get the data of one column, I can predict directly, right? So that is what all stats is all about. So you have to, I think stats will give you a very good base to become a machine learning scientist.
Okay, okay. So Vishal is asking the difference between supervised and unsupervised machine learning.
Okay, yeah. So if you see what actually supervised machine learning is, like in which you are aware about the like for machine learning, you should have something called as training data set, right? In training data set, you have like columns called as like features and target, right? Now, target is basically a predictions, right? Now, if you train some model on which the target is available, that is called as supervised learning. The data in which the target is not available is called unsupervised learning, right? Just take an example of supervised learning is like uh, this. There's some weather condition, you have to predict whether it will rain or not, right? So you have a data set in which for different weather condition you have different predictions, right? Now that is called a supervised learning, right? Now, if you see about unsupervised learning, is like you do not have any training data set. Basically, one of the example of unsupervised learning is clustering, right? you do not have target variables, but actually how that unsupervised learning works is like you just try to make a cluster of common data set, right? In that way, you just try to predict that whether it will be true or false. So, like just take example of like how many people are there in one area, how many people will buy things in one area, right? Just take a property example, right? Now just see like how people are being clustered. That is how that unsupervised learning works, because always you cannot expect that you have a target variable to train your model with. So
Right.
yeah, that is all about unsupervised learning.
Okay, great. What is the difference between data science and deep learning? Is it only the matter of data which is used in
Yeah.
both?
Yeah, so I think both are like subset, like it's a controversy, like who is a subset of each other. That is always a controversy. So data science is like it comprises of multiple things like machine learning, deep learning, computer vision, everything it comprises of. But deep learning, you call something as deep learning, is like when you create a very huge model, right? So when you talk about like if I do not know how many people are aware, but if you know aware about like neural networks, right? You can find very huge neural networks. Like they have like 1,000 neurons in each layer, and that could comprise of like 1 GB of neurons, right? So that is called as deep learning, in which the size of the model is very huge, right? That the training part is also very complicated. The prediction part is very complicated. So that is called as deep learning. Basically, you can see that in computer vision problem where you have images, where you have videos, that part the data becomes very huge, even the model becomes very huge. Now everything comes under a like umbrella of data science, right? Now data science supervises of everything. That is why we call it the data scientist. So data scientist is like aware about machine learning, about deep learning, about computer vision and stuff, right?
Okay. So our next question is about AWS certification. Our mentee is asking whether it is practical to go for the certification right after you finish your machine learning course, since they require a minimum 2-year work experience.
Yes. Now about AWS certifications, I ideally do not have an AWS certification, right? You can have multiple things, like you can have a certification like AWS or Microsoft Azure, like both are equivalent. Like both are like cloud deployment. Basically, if you see AWS and Microsoft Azure, both are like related to cloud itself. Like both says like both are like cloud products, right? You can deploy your model, you can deploy your products, and ultimately people can use it, right? Now certifications, what I would say is like uh, I would say it is a plus point for you. Like whenever you apply for any job role, getting a certification is a plus point. But ultimately, I would say that is not a necessary condition for you to get a certification, right? Now, now how the companies expect is like you should be aware about like how machine learning works, how the things work. But because you will get a revamp time when you join a company, like you learn multiple things, how company functions and those things. So I think that is, if you get an AWS certification, that is good. But I would say that is not a like mandatory thing for you to get it.
Okay. So if you want to avoid Python, so which is the other language that you should go for?
Yeah, I think you can do machine learning in all the languages, right? C++ you can do, Java you can do, even C also you can do. But it all comes about that what is more friendly to us for development, right? With respect to that, there are two top languages that comes is like that is Python and R, right? Now, why Python and R are very preferred languages is like they have lots of libraries. Now, if you say like you want to do machine learning in Java, right? That is completely feasible, right? But what you have to do, you have to write everything from scratch, right? Because it doesn't have inbuilt libraries. It doesn't have like libraries for like creating a graph or something. So ultimately, you have to do everything from scratch there, right? So it all comes about the convenience and something. So that is like people can like prefer Python or R. Now, if you do not want like to go with Python, you can go with R. Both are like well-used languages for machine learning. So, but as I said earlier as well, like if you want convenience, you can go with Python.
Okay. So our next question is that most of the ANDU NG courses are conceptual and very deep. So what approach should be followed while learning those models? Basically, Python hides all implementation of algorithms. So what is the approach that you
Yes.
suggest?
Yeah. So if you think that it's very conceptual and you can avoid it, I think you cannot go very long, right? Because if you are just dependent on like using the inbuilt libraries, ultimately at a certain point of time you will like become like freezed, right? You do not have anything new to implement. Why that course is very important is actually you get a gist of actually how the things work, right? What is the mathematics behind the things? So if you see the courses in like colleges itself, like my college had machine learning courses. So they will teach you all the mathematics, right? How the image processing works, how. So if you see like if you're given some new task, you do not see any model that can be used for like implementing that task. Ultimately, you have to design your own model from scratch, right? And if you do not know how to actually like design those models, how the mathematics works, ultimately like you cannot be able to achieve a very good accuracy in that. So why that course actually like what actually course do is like they give a base for you to learn mathematics from machine learning, right? If you see that course start with like gradient descent problem, like how the things work, how you adjust the like error ratio, how you increase the accuracy. So that part like is very essential for you like to learn. I would say like just spend some time in theory. That is very important. Ultimately, you have to like convert that into a practical thing. So I would say like once you complete that course, at the end of course you can just go to Kaggle and just try to implement that thing. So if you see that any problem that is a simple like stochastic gradient descent problem, you can just go ahead and implement that. So when you implement that, you can just go ahead and just use one simple line to get that thing done. But ultimately, you know that how that things works in like behind the scenes, right? Yeah.
Okay. Okay. So the next question is about confusion matrix. What is a confusion matrix?
Uh, okay, so if you see confusion matrix, right? So it basically tells you about what is your recall and what is your like accuracy percentage, right? So that confusion matrix contains like out of the total predictions, how many were actually suppose just say I was predicting like whether it will rain or not rain, right? Now I have 100 data out of which I predicted that 80 will rain and 20 will not rain, right? Out of 80, how many were actually raining, right? Now my prediction, how my prediction is judged is like how actually the things will perform and actually the things will happen, right? Now if I say the prediction is this, and if that happens, then that my prediction becomes true, right? If what I predicted doesn't happen, then my prediction becomes false. So if you create a like matrix out of that becomes a confusion matrix, right? Now that matrix is actually used for like seeing that like how your model works, how accurate your model was, or how good the recall your model is. So that is what the purpose of like confusion matrix is.
Okay. Okay. So how do you think is hacking connected to machine learning?
Sorry, I didn't get that question.
How is hacking connected to machine learning?
Hacking, right?
Yeah.
uh, I'm not sure. I didn't do any hacking on machine learning. So like
Okay.
hackers are like not like domain dependent. You can hack anything like whatever you want. So I cannot like comment much on that, like how hacking is used for machine learning.
Okay. Okay. Our next question is, can we use Linux for machine learning?
Uh, yes. What I would say is like Linux is not a language. It's a operating system. So yeah, I think the operating system
Okay.
doesn't. Yeah, operating system doesn't like what operating system you're using. Ultimately, like whether you open Java in Linux, whether you open Java in Windows, will be in Python itself or R itself. That won't be like operating system dependent.
Okay. Okay. So the last question is that do companies care which language we program in? Be it
Uh,
R or Python or any other
uh,
language?
uh, I would say like as a for a hiring purpose, they it doesn't matter a lot because if you see all the hiring things, so ultimately like you are given a problem statement, you have to predict, right? They do not care in between what happened, like what language you use, what model you use. They do not care, right? Ultimately, they will check your prediction, like out of your total prediction, how many were correct, how many were incorrect, right? Now that will be your like how the company will judge you. Maybe at the later point of stage, if if some company has a requirement, okay, they want someone working in Python, they do not work in R. Like suppose take Facebook. Like Facebook, I'm aware that they work in R, they do not work in Python, right? If you see Google, they work in Python, they do not work in R, right? So every company have different requirements, but ultimately that doesn't matter a lot, because that will be covered as part of your, like when you join a company, you will be given some like trainings and those things, so that will be covered there, right? Because if you know a concept, you can implement in any of the languages. So yeah,
Right.
that was one point.
Right. So I think, Piyush, that's about the questions, I guess. Guys, I have dropped a feedback form in the chat box. Kindly do fill the feedback form so that we can continue bringing such amazing sessions for you. Great. Piyush, before we move on, could you please drop your LinkedIn profile or your email address so that our mentees can connect with you?
Uh, yes.
Yeah, please do that in chat box. And thanks a lot to the Qfuss team for collaborations. Mentees can check out their website at www.qfuss.com. Thank you all for joining in the session. I hope you enjoyed attending the session as much as we enjoyed organizing it. Thanks a lot for joining in. Thank you so much, Piyush, for coming
Yeah,
in,
thank
for
you.
giving
Yeah,
us.
thank you so much. Yeah.
It was a fabulous webinar and we had fun. I hope you did too.
Yeah, same. Yeah, thank you for like considering me. Yeah, thank you.
That's not a problem.